everyone, let's take a look at section 25.4, which is optimization. In the last section, we found our maximum points or minimum points when the problem gave us an equation and we needed to type the equation in our calculator and find the maximum and minimum points. So we should be experts at that. So we're going to take it one step further in this section. Instead of the problem giving us the equation, we need to come up with the equation. And so there's 3 overall steps to do this. The first one is to identify the equation or formula that we need to find the maximum or minimum of. So the problem will say, find the maximum volume or find the least cost or something like that. And so then, like for example, if it says find the maximum volume, then we'll have to find an equation for the volume of whatever shape they're talking about. Okay, so that would be step 1. Step 2 says replace all of the variables except for one with something else that only contains numbers and that remaining variable. So, like if we have the volume of a cylinder is pi r squared times the height, then we either have to replace r in terms of h or replace h in terms of r. So we only have one variable. Okay, and then number 3, it says type the equation in our calculator to find the maximum or minimum and interpret the meaning. Well, that's what we were doing in the last section. Okay, so for example, your grandma calls. She made a large batch of your favorite cookies, and when she went to the store this morning, they had your favorite candy and trail mix on sale, so she bought you some. She's putting together a care package for you, but she doesn't have a box to mail them in. She looked around her house and found 2 rectangular pieces of cardboard that are 15 inches by 12 inches. She plans on cutting squares out of each corner and folding up the sides to make 2 open-top boxes. She'll use one for the bottom and one for the top. She wants to cut squares so that the resulting box has the largest volume so she can mail you, her favorite grandchild, the most goodies. Since she hasn't taken Math 1230, she doesn't know what size to cut the squares. What size should Grandma cut the squares so the box will have the largest volume? Okay, so largest volume. So we're going to write an equation for volume and then somehow replace some of the variables. So we end up with an equation for volume with just one variable. Okay, well, in order to make sure we understand what's going on with this problem, I found this cool applet that describes the situation. So let's go and check out that applet. Okay, so here's the applet. The first thing we need to do is change the rectangle's width to 15 and its length to 12. Or you could have switched them, it doesn't matter. And then what we want to do is play around with how big we should cut the squares. So we're cutting the squares out of each of these corners. And then what we're going to do is fold up these sides or the tabs, and it'll form a box. So if we look over here on the right, when I slide it up, we're going to form a box. And so Grandma's going to create 2 of these. One will be the bottom and the other will be the top. Okay, so what size will give us the largest volume? Here it says cut is equal to 1, so that would be 1 inch. And we can play around with it. And if you notice over here on the right, it says volume. And so we can play around with this and make the cuts smaller or bigger. And we can see how the volume will get bigger and then smaller. And so somewhere over in here, we're going to have the largest volume. So there's 177, 176. Oh, I know, looks like it's about right there. So if we slide this other slide, we can see that the box will fold up and it will give us our largest volume, which is 177 square inches. Okay, so hopefully we understand what's going on here. And let's go back to the problem. Okay, so the first thing we need to do is come up with a formula for the volume and to replace the length and the width with something. So the volume of a box is length times width times height. Well, our length was 15 inches, but then we cut X inches out of either side. And so actually the length of the box, which is from here to here, is going to be 15 minus an X minus another X. So 15 minus 2X. And then the width. Well, the width was 12 inches, but then we cut X inches out of both sides. And so the width, which is right here, is going to be 12 minus 2X's. Okay, and then the height of the box. Remember when we folded the box up? The height would have been whatever we cut out here, and so it'll be X. Okay, so now we have an equation with just X's in it. So now we need to find the maximum. So let's type it into our calculator. Note, reasonable values for X range from, well, it would be 0, in other words, if we didn't cut anything out, to the biggest would be 6. Because if we cut 6 inches this way and 6 inches this way, then we cut everything out. And so 6 would be the biggest value. And so now that we have reasonable X values, we can type this into our calculator and find our maximum point. And that maximum point is about 2.21 and 177.23. Okay, so what the heck does that mean? Remember, our X's were the side of the squares that we would cut out. So this would be the square length. And then 177, that's our Y value. Well, our Y value is really the volume. So tell Grandma to cut the squares that are 2.21 inches by 2.21 inches out of each corner, and you'll end up with the largest volume of 177.23 square inches of delicious Grandma's goodies. Okay, so please go on to the next video when you're ready, and I'll see you then.